Okay, class, we're about to start section 9.2, part 1, adding and subtracting radical expressions. Like radicals are radicals with the same index and the same radicand. Basically, it goes like this. Say we had the fifth root of x. In order for this to be added to, in order for this radical to be added or subtracted, whatever is added or subtracted to must have that same index and that same radicand. So it must have 5 for the index. Well, let me make this a 15 so you'll see the difference. It must have 5 for the index with the radical, and the number under the radical, which is the radicand, must be the same. Now, if we look here, we have the same index, but we have different values under the radical, so they're unlike radicals. Then we have the square root of x and the square root of x squared. Now they both have the same index, but they do not have the same value under the radical. It's unlike. We have the square root of x and the cube root of x. They do not have the same index, so they're unlike. Now we look here. We look again at the radicals. We have the same index. We have the same value under the radicals. They are like radicals. Now we come here. We look at the index. This negative sign is not with the 5. This 5 is a positive 5 for the index. This negative is on the outside of the radical. So these have the same index, and under these radicals they have the same value. So they are like. Now here we have the same index, but we have different values under the radicals. The radicands are different, so they're unlike. And the same thing here, except for we have different indexes, so they're automatically unlike. Okay, now to add or subtract radicals. Simplify all radicals that are part of the expression. Combine like terms by adding or subtracting the coefficients of the like radicals. Okay, so this is how we would do it. First of all, we have 72n and 18n. We have the same index, but we know that they are not like radicals because under these square roots, these are different. But first, let's do this. What is the highest perfect square in 72? We know it's 36, and we know we will have 2n left over. The highest perfect square in 18, we know it's 9, and we had 2n left over. Square root of 36 is 6, square root of 2n. Plus, the square root of 9 is 3, square root of 2n. Now, you just witnessed here that our indexes are the same, and now our values under the radicals are the same. So we would add their coefficients, which is 6 and 3. 6 plus 3 is 9, and we would carry the radical over. Now we come here to B. We need to do the same thing we just did for A. Take out the highest perfect square, so it'd be square root of 4, square root of 5, minus 3. Highest perfect square in 63 is 9. That'll leave us 7. Minus 5. The highest perfect square in 180 is 36. And that will leave us 5. And now we have 700. The highest perfect square in 700 is 100. And we know that will leave us 7. So now we go through here. This will give us 2 square root 5. Now we know the square root of 9 is 3. 3 times negative 3 is a minus 9. And we have square root 7. Now we have minus 5. Square root of 36, we know is 6. 6 times a minus 5 is a minus 30. And we have our square root of 5. Now the square root of 100, we know is 10. And we'll bring down our square root of 7. Now if you look here, we do have some like terms. We have 2 square root 5 minus 30 square root 5, which is a negative 28 square root of 5. Now we have a negative 9 root 7 plus 10 root 7, which will give us a positive square root of 7. Or you could put positive 1 square root 7. But this is our final answer. Now we scroll down here to C. We have 3a square root of 8 8ab cubed minus 4b square root of 18a cubed b. They have the same index, but they do not have the same value under the radical, or the radicand is different. So we have to pull out the perfect squares. So this would be 4, leave us 2. A goes here 2. This will be b squared and leave us b. Minus, this would be 4b. The highest perfect square in 18 we know is 9. Leave us 2. Highest perfect square in a cubed is a squared. Leave us a. And we know b is not a perfect square. So here the square root of 4 is 2. 2 times 3 is 6. Square root of b squared is b, so that would be 6ab. And then now we will be left with square root of 2ab. Now we have minus. Square root of 9 is 3 times 4 is 12. Square root of a squared is a times b will leave us ab. We had a square root of 2ab. Now if you notice, we have the same index and same value under the radical, so we combine the like terms here. 6ab minus 12ab is a negative 6ab. And we'll be left with the square root of 2ab. And this is our final answer. Now, we scroll here to the next page, example 2, the nth root example. It says, perform the indicated operation and simplify. Now, this page is not counted, but when you do your homework, you may need this here for your homework. Now, we're going to do the perfect cube of 128. So we know the highest perfect cube in 128 is 64, which will leave us, actually I put too much space here, but I'll do this. This will be 2. Now the cube root of x to x to the 7, we know the highest perfect cube is x to the 6, and that'll leave us x. Now plus, we have x, and the highest perfect cube of 16 is 8. And that'll leave us 2 left over. And then the highest perfect cube in x to the 4th is x cubed, and that'll leave an x. Cube root of 64 we know is 4. Cube root of x to the 6 is x squared. And we'll bring over our cube root of 2x. Now plus, the cube root of 8 we know is 2. Cube root of x cubed is x times x is x squared. And we have the cube root of 2x. Now they have the same index and they have the same radicand. So now we combine our like terms. We have 6x squared times the cube root of 2x. Now we go here to b. Now with b, we have the 4th root of 2x to the 3rd y. We know that there's no perfect 4th root here. We have the 4th root of 2x to the 3rd y. Since we have this here, we can combine this. 3 minus 8 we know is 5. And we have the 4th root, or negative 5. It should be negative 5. We have the 4th root of 2x cubed y. So that is our final answer. Now we come down here to c. Now let's take a look here at c. We want to see if we have some like terms here. We know 4 minus 1 we know would give us 3. So that took care of those like terms. Now the only other like terms we have here is the 4th root of 4, 4th root of 4. So we have a negative 6, 4th root of 4. We have a negative 8, 4th root of 4, which would give us a negative 14, 4th root of 4. Now we know that this isn't a like term, so we would just carry this over. This is a positive 3 cube root of 4. And we're done. Now we come here to d. We still want to combine the like terms here. Now we have 2 cube root of x minus 6 cube root of x, which is a negative 4 cube root of x. Then we have negative 4 root x plus 3 root x, which will give us a negative square root x. And that is our final answer. Now, we're about to start section 9.2, part 2, multiplying radical expressions. Now here what we have, this is one factor times another factor here, or one term times one term. So we do not use the distributive property. All we do is multiply the coefficient times the coefficient, which will give us negative 18, and a radical times the radical, which will give us the square root of 48x squared. Now, what we need to do next is this here. We need to pull out any perfect squares we have here. So we have negative 18. The highest perfect square in 48 is 16, with 3 remaining. And x squared we know is a perfect square. The square root of 16 we know is 4. And 4 times a negative 18 is negative 72. The square root of x squared is x times the square root of 3. And that is your final answer. Now we move on to the next thing here. We have watch out for distributive laws. Now here we're going to distribute this 3 across everything in this parenthesis and this 5 across everything in this parenthesis. So we add 3 times the square root of 2x minus 12 cube root of 2x plus 15 cube root of 2x, and then minus 30 square root of 2x. Now we're going to combine like terms. 3 times the square root of 2x minus 30 times the square root of 2x to give a negative 27 square root of 2x. Now negative 12 cube root of 2x and a positive 15 cube root of 2x will give us a positive 3 cube root of 2x. And we're done with that problem. Next we come to the FOIL situations. So we'll distribute this like we have done other FOIL problems. 2 times the square root of a times square root of a is 2 square root of a squared. 2 times square root of a minus 3 square root b will give us a negative 6 square root ab. Square root of b times a is a square plus square root ab. And the square root of b times a minus 3 square root b will give us a minus 3 square root of b squared. So this will give us 2a, negative 6 square root of ab plus the square root of ab will give us a negative 5 square root ab. And negative 3 times the square root of b squared will give us a negative 3b. And we're done. There's nothing more we could do with that problem. Now we come here. This is parenthesis squared. So we know we'll write this parenthesis twice. So then we will have 16 times the square root of 9x squared. And then we will have a minus 20 square root of 3x. Then we have minus 20 square root of 3x. And negative 5 times negative 5 is a positive 25. Now, the square root of 9x squared is 3x times 16 is 48x. And then this will be a negative 40 square root of 3x plus 25. And we're done. Now we come to objective number 2, multiplying radicals with the different indices. You must convert these to exponent notation to multiply. So we would change this to x to the 1/4 times x to the 1/6. We know that these indexes, we take the reciprocal of the indexes. Now, whenever we have the same base, we know we add the exponent. So it'll be x to the 1/4 plus 1/6. Now, we know our common denominator here would be 20. Well, we could use 12. We don't have to use 24. So this would be 3/12 plus 2/12. And 3/12 plus 2/12 will give us x to the 5/12 power. And we could rewrite this as a radical. It would be the 12th root of x to the 5th. So this is the final answer. Now we come to this next problem. We have to write this parenthesis twice. because this is squared.